Welcome everyone. So in this video tutorial I will start from without DG calculation. So without DG calculation means we have not incorporated distributed generation, or you can say battery energy storage system, electric vehicle, or anything which we have actually to optimize later. So this is actually the base case. First we will find out the results, and later on we will make comparison without DG and with DG. So also let me explain some MATLAB parts. So here are the script files, different files which are actually linked with each other. So whenever I open a file, it have different kind of instructions inside it. So this is actually a loadflow.m. This is actually a script file, and all these files have different kinds of instructions. So here is the workspace section. A bit later I will show you that every variable which we initialize here will be stored here, and in command window when we will completely run the program, the results will be shown here. So let's continue again the without DG case. Another thing, here the load flow considered is backward, forward, sweep load flow, and the optimization is here considered is the PSO. So optimization can be of any kind. It can be of ABC, it can be of PSO, or anything. Okay, so both these are different projects. This one is different and this one is different. So I will keep them both at the same time, so we can get idea about different networks. So this is actually 69 bus system, and this is with the 33 bus system. Okay, so in without DG calculation, let's continue. So initially I have to load here uh, the line and load data from 69 bus system. This is the start of the program, and we have to clear each and everything. So for example, let me left click here, and there is a debugger here, and when I will click the run program, and now we can run our program in steps. I'm just opening the window so can see the progress of recording. So now in this way we can run the program in different steps. For example, I click run. Okay, and up to now we have two variables that are PG and QG, which are initialized here. So here I have line data and load data, which I also explained previously that files are linked with each other. So when I click on step, so now our load data is load data, and the content inside the load data 69 bus.m file is now in our variable name m. So let me double click here, and here you can see that we have the load data. So this is the second column represent real power at each bus, and the third column represent the reactive bus at each reactive power at each bus. Okay, and so and in the L variable which is here, just let's see. So here we have uh, the line data for IEEE 69 bus system. Similarly, if we have 33, we have here the line data for 33 bus system. So this is second column from bus to bus, resistance, reactance, and similarly all the parameters. So after that we have to calculate the branches and number of buses, just considering grid capacity and uh, voltage, reference voltages, and here is the conversion calculation from uh, conversion into the per unit in the next step. So by dividing ZB, we have our real and let me red circle here, and when I click on continue, then will cursor uh, continue up to the red circle. So okay, and now here you can see that in our R and X we have our data in per unit. Previously it were the fixed numbers, uh, complete numbers, and here we have the per unit values. So if I want to continue one step, then it will uh, complete each and every step, and now we are converting our real and reactive powers from kilowatts into the per unit. And let me click on step here, and let me click on continue. So here in P and Q we have real and reactive powers, real power, and here is the reactive power in the per unit. Okay, and here we are going to let me explain what it means and what does actually they are doing here. So this is actually a standard code, and it's developed very earlier. So we have to put -1 at from bus and 1 at to bus. For example, if I want to for example add 45 and 45 and 46, so this will be the from bus, and this thing will be to bus. So we have to put -1 at from bus and 1 at to bus. So it's just have to check each and every parameter. So let me click a red circle here, and before let's step, and now let me check what is the C here. So here you can see you can check the variable both way. Even you can put here and click on enter, or you can also open C from the workspace by putting pressing double click. Okay, so in this step we are putting a -1 at from bus and 1 at to bus. So let me click on continue and complete this step. Okay, and now let's see what's inside the C. So here you can see that we have -1 and 1, 1 to 2, it means 2 to 3, 3 to 4, 4 to 5. So we have to so in this way inside the C we can get an idea that this is the representation from bus to bus from 12 to 13. And let me show you something like so this thing. So this is 36, it means 36, and so I have to check in the same row. So 2 bus is 36, and let's see from bus is 3 to 36. So let's verify. So here is 3 and 36, from 3 to 36. So in this way this column is this section is finding out the exact what does actually how to calculate it. Okay, and now in this section we have to find the end nodes. So this algorithm is calculate the end nodes. So let me click on continue here. Okay, and let me move my cursor to the also there is a third way to check what inside that variable is. Just move your cursor there and you will see 27, 35, 46, 50. So let's verify. Okay, 27, 46, 50, 52, 35, 50. Yeah, we also have 35. So in this way, here our plan was to find out the end nodes. Okay. And I'm just skipping some details from these groups, and if you want to learn more about this sections or each file, there is already explanation available on my YouTube channel. So let me show you that one too in videos. So this is the video which you can uh, take a look at it, and simulation tutor by. And also there are a lot of discussion related to these things, so you can also take a look at the video and get a clear idea about all these things. Okay, so here we have find the end nodes. So this is the next step, and all the other steps, next steps are here, just to arrange them. Okay. And here end node, and now let me show you what does G here. So let me click on continue. Okay, and now let me just show you the G. And this G section in previous section, in this previous code, in this code we have arranged our buses. I mean, start from to bus, and from bus, and back toward the to bus, and also keeping in mind that how many end nodes we have. So from here you can get an idea that we have we have eight end nodes. It means we have eight branches. So here we have eight branches, and in each branch we have to check how buses are connected with each other. So let me move my cursor here. So it means our main branch is start from 1 and ends on 27, which also we have verified previously. And the second branch will start from 1, 2, 3, 28, 29, 30. Okay, so how does it is going now? So it means that this is our first branch, and this is also a branch. Okay, and this is also a branch. Okay, so each and every time it will starts from 1, 2, 3, 4, 5, 47, 48, 49, 50. For example, in case of 51, how does it will calculate? It will start from 1, 2, 3, 4, 5, 6, 7, 8, and then 51, 52. So in this way, let me verify to this thing. Okay, 1, 2, 3, 4, this is same. 5, 6, 7, 8, 51, 52. So in this way we have to start each time, because in case of real loads, we have to the grid have to supply the power in such a way that will start from 1, 2, 3, 4, 6, 7, 8, and 51, 52. So in this way, for example 65, so similarly we will be around at 8, 53, 54, 55, 56. So in this way it will calculating, managing, and uh, doing similar things. So now we have to rearrange the G. So on left side we have 1, and on our right side we have the higher number. Previously we have, okay, so not being, previously we have higher numbers on left, and lower number on our right. So now we have to put 1 on our left and 27, 26 on our right. Okay, So now let me click on continue, and here just move my cursor G there, and here you can see that we have 1 2 3 4 5 6 7 8, similarly each and everything. Okay, and in next step, let me I mean in this step, what we are going to do here, let me click on continue and let me show you ADJB. And now the things required here are just copy this variable also, uh, just copy this thing and clear the command window CLC. And okay, so here we have skipped the bus number 1 and starts from 2 3 4 5 6 7 8 9 10, continues and 27. It means first branch ends on 27 and next branch starts at 28. It means at an end node we have put 0. Sorry for a bit of background noise. And here we have incorporated our end nodes so that let me show here again. So at 28 number we have our end nodes. Sorry, at 27 we have this is actually the, let me yeah, 27 is end node, so it means this is end node, and on next step we have our next branch starts. So at that point, uh, algorithm the loop puts 0, and similarly at 35 and next to the 36, there is a 0 put by that algorithm. So in this way, by putting 0 there, okay, and also 2 3, just a moment. So also let me explain a bit about the second, third, and other columns. Okay, we have 8 branches, and here we have second, third, fourth, fifth. So we have 7 we have 8 branches. Previously we have 8 columns. So first one is the main and other are the correlated with it. So from here you can see that each of our you can see that 2 is at each branch. This is the first branch, second branch, third branch, fourth branch. So third is at each branch. Okay, so let me verify. Okay, so 2 and 3, each branches which are uh, each branches which are linked are actually contain 2 3. So now I have to verify that now I have to verify, and 5 branches in other words 5 branches have 4 bus, and 4 branches have 5 bus. Okay, let's consider 5. So the branches next to 5, 1 2 3 4. So 5 have 4 branches and 4 have 5. 1 1 2 3 4 5. So that's why 4 have 5 branches and 5 have 4 branches. So this is what does actually mean. So no need to consider each and everything from here in depth, but we have to get an idea that how the algorithm is performing and calculating each and everything. Okay, so let's click on continue, and there are further section, so let me again ADJB. Okay, okay. So similarly, this is the representation of our basis, and now we have skipped some parts and repetition. Okay, and based on these, and let's click on again continue. There is still some kind of rearrangement. Okay, just Previously one was not included and now one is included here. Okay, and after that there is a rearrangement, and then there is a voltage current program. So up to now, up to this point, we have calculated our up to this point we have calculated we have arranged our network to calculate the line and to calculate the line voltage current program. So after that, from using PQ and by dividing it the voltage profile, we have line current, okay, between the two buses, and then based on that we have calculated the line currents calculation, and this is the IPR line current calculation, and based on that there is a voltage profile calculation. Okay, this is the voltage profile calculation. This is the voltage, and this voltage is actually uh, for example at bus 3 we have voltages. For example, at bus number 22 we have voltage profile. So we have to minus the voltages which were dropped previously on 21 location. So this program is about that, finding the voltage profile at upcoming bus. How to get that will be the voltage profile at previous bus and the voltage drop at that bus. So that's why. So now here is a calculation and summing up and all each and everything. So let me click on the run program. Let me remove these red circles, and I want to completely run the program. Okay, so here is the real power and this is the reactive power. This is the real power at each bus and this is the voltage profile. So up to now without dg calculation is done here, and in without dg.m file. So here we have two columns. The first column is represent the real power sorry, the voltage profile, and the next column represent the real power at each bus. So this is the file. When I run it, you can get the outcomes, and that outcomes are putting into this because this file is used in uh, the main program later on for comparison. So comparison of the ABC uh, will be done with the without DG. So let me show you one more thing. ABC opening the okay. So here I have put 224 and 102. So how I get these numbers? I get these numbers from without DG calculation.m file. Okay. So these are these put here. Okay. And without DG contains the voltage profile. Okay. And let me show you that too. Okay. Here is the without DG file, and at the end of this here you can see that without dg.m. So the data inside without dg.m uh, is coming into this load flow 2 file. Okay, and later on there is a comparison and plot between the real power loss and the uh, voltage profile. So up to now the without dg.m without dg calculation. So similarly here I have another project, and in that let me first run that program. Let me click on change folder. So now we are in another folder. I'm just opening this. This is the here again there is a without dg calculation. Okay, so here our line and load data is 33 bus system. Each and everything which I explained previously is the same on without dg calculation 69, and on right I have 33. So each and everything is exactly same because it's a standard code. So just what will be the different will be the line and load data different, end nodes will be the different, branches will be the different, and the arrangement of course when we have to arrange our data, then the data will be different. Each and everything will be the same. Let me run the program here. Okay, so again 201 and 134, and let me okay On left, this is the 33 voltage profile, and on our right second column, it's the real power at each bus. 201 and 134 is also in PSO program, is mentioned here below. So it is 201 and 134 here. So in this way, without DG calculation is done, and in next program, I have to just explain how the load flow files, load flow 1, load flow 2 is considered for evaluation, and then I have to explain the optimization part. Okay, so let's continue to the step 2.